Thank you. Thank you very much. Merci, Matthias. I'm very humbled to be here. And I decided also to focus on very simple methods. So I hope you bear with me. Maybe it's part of aging process when I handle simpler methods. And I'm trying to show you the links between demography and life course in a special way, kind of macro and micro. The preface includes this one. So this is one of my favorite ways to show cultural change. I don't know if you are familiar with Google Ngrams, basically counting the words in books. And here you can see the emergence of the life course in the 70s, which is a bit going down. So please be mindful of that. So we have to change the trend. But it's still above demography, which was for a long time kind of an older field. I also track longitudinal studies, and of course to honor Harvey Goldstein, multi-level models, which are, of course, if you use multi-level models, maybe there's different kind of wording, and social statistics, which was what he had on his professorship. So basically we have to work a bit, but I did that a while ago for the 10 years of advances in life course research, and at that time the life course was clearly on an upward trend that seemed a bit exponential. So, second part of the preface, basically at the macro level, I will work on very simple descriptive statistics, and I will do more or less the same with some statistical models at the micro level. Everyone is familiar with the macro-micro approaches in the life course. What is sometimes important is to defend the idea that in addition to micro-based explanation, we also think about macro discovery of novelties. Agent maze modeling will not be shown here. It was a great way to close the micro-macro link. So let me start from the simple macro idea, and I start. And there is an advertisement here, and this has been already published, so there is more you'll see in the talk, and that's where it comes from. Of course, it comes from the book of Kahneman, of the late Kahneman and Tversky, and basically the general idea is that population change, if you think lives in the long run change from fast lives to slow lives. So our past, this is the general idea of a demographic transition, was a situation in which we were born many, dying fast. Everything was fast. We could not plan long ahead, okay? Then there is, at some point, the emergence of what we can call slow demography, something that moves slowly. This is Alfredo V words. The population change is moving like the hour hand in a Swiss watch. He didn't say a Swiss watch, but to honor our chair, I will say that. And so basically, if we are getting to slow life, everything is more predictable. No one has really tested this, to be frank. At least that was our understanding. And this is what is the idea of the demographic transition, which comes from this country as well, Malthus, saying if lives change fast, that's a disaster. Okay, lives have to change slowly. And this is exactly the demographic transition idea. We are not wasting energy in lots of dynamics. So how fast is actually population change? Do we know that? Can we measure that? Actually, in most population studies approaches, especially in geography, but in ecology, you use basically all the ways to get in or out of a population, okay? This has not been done so far. The population turnover rate is very simple. Again, very simple measures, division and addition. There are two ways to get out of a population, death and emigration, and two ways to get in, birth and immigration. The speed of macro level life change or population change is turnover rate, okay? I hope you agree. We can then later discuss. So can we measure this? For many years, it was not easy to measure that because we didn't measure well migration. Now, luckily, we have good data. By the way, what is interesting, especially for current macro level change, is to understand what is the share of change that is due to migration only. And it will, I hope I can convince you this is important. So basically, if you take the 22 paper, there is some of the analysis that I will show, and now we are finalizing a paper with Danilo Bonanno, Alessandro Di Nallo, Chiara Serra, and Christian Munter using some multiple level data of European countries. But this is, again, all macro data. This is population turnover and migration share of turnover. No rocket science. In large, these are single countries in 2015, 2020. So I hope you easily agree with me. In large countries, population turnover is smaller. In small countries, population turnover is high. Small in terms of population. Okay. New Zealand, small population, high population turnover. Switzerland, Luxembourg in Europe. Okay. And in small countries, population turnover is mostly driven by migration. Again, very simple fact. So the speed of life changes is faster now, in our days, in smaller countries. But I'll go back to that. This is, again, correlation, very simple, discovery. This is the relationship with gross national income per capita, so basically the wealth of a country. And you see, a little bit like the demographic transition. In poor countries, life is fast. But then the curve is a bit J-shaped. So when you get to high levels, speed is positively correlated with gross national income. And in particular, the share of migration explaining speed is higher in richer societies. Okay. This is all cross-sectional, so maybe we should not show that in this society. If you want a longitudinal, very simple, again, longitudinal data at a country level, I show you three. First one is Germany for 30 years. Population turnover was decreasing and then starts increasing to high levels, with the share due to migration getting almost to 65%. When was that? Syrian refugee crisis, 2015. Angela Merkel decides to open the doors to refugees, 1.2 million net immigrants. So very fast change, new lives for data collection. So this is very short. You know this country? I'm one of the born people here. And if you look at the blue, you see a demographic transition story. In the past, life was fast. In particular, the peak is around World War I and the Spanish flu, with both high mortality and fertility, but also high emigration. The country was an emigration country. Then a long, slow decline, and after 1990s, things go up and down. So basically, there is no convergence to slow level. Why? Because the migration share goes up. Country becomes an immigration country. And normally, if you want even longer data, I even found Swedish data. And of course, you can use your favorite country. And Sweden, again, in the long run, you see the decline in the speed of population change from 1875, when Sweden was provider of migrants to North America in particular. And then basically starting in World War II, the situation is stabilized with an increase in the migration share of turnover, which is mostly due to immigration. Okay? Some of the new data here, with my co-authors, we are working with European data, showing, again, no rocket science. The lower the geographical level you use, the higher the population turnover. But also, at each geographical level, more or less, turnover is going up in Europe. These are various European countries. So what you see, the lowest line is always the national level, then you get to subnational and sub-subnational level. So we reproduce basically the small, large, but also the general idea that there are trends. And these trends are due to migration. Look at the migration share of turnover in some of the European regions. It's way above 80%. Okay. Actually, it has some implication if you want to collect data for people not changing address, as you all know. This is one way to map the different areas. Here, dark means slower change. So Italy traditionally is low. In particular, we show that it's low. And some areas of Britain, Spain, and Germany have fast change. And the migration share of turnover is what is driving, in most cases, this fast change. Also at the European level, using subnational data, NAS3, one can show that richer areas have faster macro changes in lives. And these faster macro changes in life are, on average, driven by migratory movements. So this is the macro. If there are no clarification questions, I go to micro. And micro, of course, it's a bit of a different story. How fast is one specific life, or how fast is on average in a population the life course? How many events in particular are people experiencing? So you can do it in many ways. Usually there are two complementary approaches in life course research. One it tended to be more explanatory and the other one more descriptive, but things have changed over time and there are folks like Matthias putting them together. But let's say in sequence analysis, you measure the number of events, entropy, and other complex measures to understand whether there is a lot of happening in a life course, okay? In event history analysis, you can have what I will use here, very simple measures. These measures are inspired by a keynote to the Population Association of America of Ron Rinfus, 1991. Ron Rinfus in 1991 basically depicted some rates over age for fertility, migration, marriage, leaving school, and unemployment. And basically, his idea was, it's clear to all of us that the most dense period in life is between the ages of 15 and 40. Okay? Make sense? All the rest is slower. Can we do the same? Basically, yes. Thanks to the generation and gender survey and other data, can we really understand whether lives are slow or fast, and maybe and that will be the macro connections, in which context these lives are slow or fast. So basically, the very simple idea, this is an unpublished paper with Nicoletta Balbo and Elia Boschetti, is, okay, you can take hazard rate of any event, and you just sum them. And if you cumulate and integrate, you count the average number of events. Again, not rocket science, very easy, but it allows us to understand how the speed of the life course may change over time and space. And so what we do, we use the GGS harmonized histories plus some data from Spain, US and NSG. And this is, of course, one limitation. Unfortunately, there is no migration here. It's only family, fertility, and household events. So births, marriages, divorces, unions, and dissolutions. Of course, these are, in most cases, you understand they are relevant life course events. At least, normally they have some consequences. So this is, for instance, we were putting all countries together and comparing 4 cohorts, large cohorts, because this is what we can do with the data. And what we see immediately is that the youngest cohort has a faster life later than the earlier cohorts, and the levels are lower. Okay? The rest, and this was already starting in the 61 to 80 cohort. Okay? You are curious to see what happens by country, just bear with me. This is, for instance, the integral of the hazards. How many events? You basically have the cumulative number of events. In the end, we are probably getting there with higher number of events, even if this is postponed. Okay? This is at any age, the average number of events. So, slowest life courses, of course, Italians. I mean, we have to eat, and our friends in Spain, anyone's from Spain here? No? Oh, siesta and all these things. And so basically, my PhD thesis was on late transition to adulthood, and so not by chance. This is showing up, basically. You see the peak of the 1920-40 is declining. This is a bit against the idea that life courses are getting faster. So if you think life course research is the opposite of the macro demography. In macro demography, the idea, which was wrong, was, okay, population change is getting slower. We don't see that. And here, the idea, life courses are getting faster. Maybe not here. Maybe somewhere else. So this is one way to show just the average, the cumulative number of events by cohorts. And because if you get the cumulative, you need to have some time to compare them. The last cohort is cut. And this is a sort of standard comparative life course, very simple graph. Of course, Swedish, the second demographic transition, complex life courses, up. They are ordered by average number of events in the last cohort. And again, Italians are the lowest. And you see the difference in the average number of events is enormous. If you look at the last cohort between Sweden and Italy. Sweden, Norway, US, and so on. Basically, Southern Europe at the bottom, Eastern Europe, and then West, Nordic countries, and US. So basically, you could say something like, in some countries, life courses are getting faster, as predicted by those who studied these countries and said the whole world is going to move to faster life courses, which is true for the countries up. But then there are some weirdos, Spain and Italy in particular, who do the other way around. Okay. Let me check. Education. Of course, there is a stratification in the speed of life courses here. Basically, let me try to explain. The green here is the highest educational level, the red is the middle educational level, and we cannot always do everything. This is something we have still to work on. But you see that in some countries there is a big distance. Look at the US, where the literature is mostly Sarah McLachlan, basically two kinds of lives. You see that distance between the two groups. In other countries, for instance, Belgium, basically, in terms of pure numbers, it's the same distribution. Okay. And multi-level perspective, again, Harvey Goldstein, I wanted to present something with a multi-level model. And what do we do? First of all, very simple correlation. We take the cohorts and the Human Development Index basically assigned to the average situation of that cohort. And these are the same countries you saw before. So all the points are cohort and country. And basically, what you can see in general, a positive relationship. So maybe life course theory was fine. With human development, it seems that life courses are getting faster. Okay, there are the weirdos, but again, they're kind of strange countries, but this is actually what seems to be observable. And of course, you can run a very simple multi-level model with a number of events. So this is not an event history multi-level model, it's just a model with a number of events, like age 40. The first model is not with a macro level variable, and so you show that very easily that women have faster life courses, and there is a negative effect in years of education. But when you do the proper multi-level and you insert Human Development Index at the country cohort level, positive relationship. So the interpretation, the human development is between 0 and 100. So this is basically rationalized from 0 to 1. It will be 3 events if you move from 0 to 100. So basically, first of all, it's unclear whether life course is getting faster or slower. If you look at macro level data, scale matters. So life courses are, if you think about population level for smaller countries and regions, development matters at the macro level for most advanced societies, but also for the speed of life course at the individual level. And we saw that with the multi-level models. We are not really able at the moment to make a big sense of the social stratification aspects. So My conclusion is that life courses are fast and slow. And I thank you very much, and I'm very humbled to be honored by a prize with the name of Harvey Goldstein. Thank you very much for your attention.